Find the normalization constant n over the interval negative a to positive a for a given wave function psi of x equal nx into bracket a squared minus x squared. Welcome to LIB Academy, and we'll be looking at normalization of the wave function with practical problems. The general Schrodinger equation, which is the fundamental equation in quantum mechanics, is a second order partial derivative differential equation. So solution of this gives us something called wave function, which we usually use psi to represent those functions. And it turns out that solution from this gives us a lot of wave functions in terms of psi, like any other partial derivative second order differential equation. Solution from it will give you a lot of wave functions. But Max Born said that the absolute square of the wave function should have something to do with the probability of us finding a particle in the system. And if we integrate from negative infinity to to positive infinity, which is the entire space, we must find a particle there. And the probability of us finding a particle there should be equal to 100%, which is 1. It shouldn't be 0.2, which is 20%, or minus 0.2, which is minus 0.2%. Because it turns out to be difficult for us to define probability in terms of minus values. It's kind of not making sense. So Max Born said that if we take the absolute square of the wave function and its conjugate, or the wave function simply integrate from negative infinity to positive infinity, or the entire space, the probability of us finding a particle within that space should be equal to 1, which is 100%. But because solution from the Schrodinger equation gives so many wave functions, some of the wave functions turns out not to give us a positive result to interpret. Can get negative probability. So to solve this problem, the wave function that should actually describe a row system should be positive, lead us to normalization of the wave function. Normalization of the wave function. And normalization of the wave function simply means that the wave function that is not normalized, we should add a certain constant to it and take its absolute square and integrate. Then after integrating, we should get 100% probability of finding the particle within the system. That is if the particle exists. And this n here, when we solve it, becomes a normalization constant. So in this case, we are looking for a constant that when we multiply by the wave function, will give us a 100% probability of finding a particle when we integrate throughout the entire space. So in this case, this wave function, we can be able to use it to describe, predict physical systems. And multiplying the wave function that we get from solution of the Schrodinger equation does not change anything, because it turns out that from second order partial derivative equation, if you solve it, you get a solution, and that same solution you multiply it by a constant, it doesn't change anything. So that is what you need to know. The question indicated that n is our normalization constant here. In this case, the normalization constant has already been included in the wave function. We'll just have to solve and look for its value. Normalization constant, to solve it, we are going to take integral from negative a to positive a, the limit given to us, absolute square of psi of x squared. The x, since it is in terms of x, equal 1. And we know that psi of x is the same as this whole thing here. So we just take integral from negative a to positive a, absolute square of everything here. So n x into bracket a squared minus x squared into bracket absolute to the square, the x equal 1. So we can go ahead and simplify whatever is under the absolute sign. So n squared, n to the power 2, n to the power 2. So integral from negative a to positive a, n squared, then x to the power 2 gives us x squared, and this whole term multiplying, raising to the power 2. So a squared minus x squared all to the power 2, the x equal 1. And since n is a constant, we can factor it out. So n squared integral from negative a to positive a, x squared into bracket a squared minus x squared all to the power 2 dx equal 1. If we have from basic mathematics a minus b to the power 2 and we want to simplify this, first of all we square the first term, which is a squared, then multiply the power by both terms. So 2 multiplied by a multiplied by minus b is going to give us minus 2ab. Then squaring the last term, which is b to the power 2. So let's apply this idea here. So we are going to get n squared integral from negative a to positive a, x squared into bracket. So a to the power 2 to the power 2 again gives us a to the power 4. Then 2 multiplied by a squared multiplied by minus x squared gives us minus 2a squared. Sorry, minus 2a squared x squared. And now we square the last term, x squared to the power 2 gives us positive x to the power 4. Then the x equal 1. Now let's expand the bracket. So n to the power 2 integral from negative a to positive a. We want to expand the bracket. So x multiplied by a to the power 4 gives us a to the power 4 x squared multiplied by 2 to the 2a to the power 2 x to the power 2 gives us minus 2a to the power 2 x to the power 2 multiplying x to the power 2. Since they are of the same basis, we add their powers, giving us 4. So x squared multiplied by x to the power 4 plus positive x to the power 4 gives us x to the power 6. Since they are of the same basis, we add their powers. Then the x equal 1. The next thing we want to do is to integrate the whole thing with respect to x. Then if we have x to the power n and I'm integrating with respect to x, it's going to be x to the power n plus 1 all divided by n plus 1. So let's do that. So integrating x to the power 2 with respect to x is going to give me x, the power will increase by 1, which will give me x to the power 3. Then I'll divide everything by 3. So let's apply the same idea here. So we are integrating n to the power 2. So we are integrating with respect to x. So wherever we see x, we integrate. So we are going to have a to the power 4, x to the power 2, integrating will be x to the power 2 plus 1, giving us x to the power 3, and divide everything by 3, minus 2 a to the power 2, x to the power 4 gives us x to the power 5, or 5 all over 5, plus x to the power 6, integrating gives us x to the power 7 all over 7. Now let's indicate our integration limit. Minus a to positive a should be equal to 1. So now n to the power 2, we first put in the upper limit. So wherever we see x, we replace it by positive a. So a to the power 4, x to the power 3 becomes a to the power 3 all over 3, minus 2a to the power 2, x to the power 5 becomes a to the power 5 all over 5, x to the power 7 becomes a to the power 7 all over 7 into bracket. Then minus, we now put in the lower limit. Wherever we see x, we put in minus a there. So a to the power 4 and then minus a, x to the power 3 minus a to the power 3 all over 3. So minus 2a to the power 2. So x to the power 5 becomes minus a to the power 5 all over 5. Then plus x to the power 7 becomes minus e to the power 7 all over 7, all in bracket equal 1. So let's shift it here. Let me shift this whole thing here. So we are going to get n squared. Let's simplify whatever is in the bracket. So e to the power 4 multiply e to the power 3. Since they are of the same basis, we add their power. So e to the power 4 plus 3 gives us 7 over 3, minus 2a to the power 2 multiply a to the power 5, 2a to the power 7 all over 5, plus a to the power 7 over 7. minus, let's simplify this term here. So a to the power 4 multiplying minus a to the power 3. Since the power of minus a is an odd number, the negative sign will affect this. So this whole thing becomes minus a to the power 7 becomes minus a to the power 7 over 3. We have minus a to the power 5 here. Since the power is an odd number, it will affect it. So we are still going to get minus going to give us plus 2a to the power 7 all over 5. And here we have minus a to the power 7. Since the power is an odd number, it's going to give us minus a to the power 7 over 7, then all equal 1. So let's simplify everything. We are going to get n to the power 2, a to the power 7 over, is this 3 or 9? 3, right? 3 minus 2a to the power 7 over 5 plus a to the power 7 over 7. 7 minus minus gives us plus a to the power 7 over 3 minus multiply by positive 2a to the power 7 will give us minus 2a to the power 7 all over 5 minus multiply by minus a to the power 7 over 7 gives us positive a to the power 7 over 7, then bracket all equal 1. Now, is there any cancellation that we can do? So we have like terms here, a to the power 7 over 3 and then a to the power 7 over 3. So adding the coefficient, we have one of them here and one of them here. So it becomes 2 a to the power 2a to the power 7 over 3. It's more like taking the coefficient. Here is 1 over 3 plus 1 over 3. And they are all multiplying a to the power 7. So they are the same. So we have one of them here, becoming 2 a to the power 7 over 3. So now let's look at this term here. What do we get? If we add them, we are going to get minus 4. Taking minus 2 over 5 plus minus 2 over 5 gives us minus 4 over 5 a to the power 7. And we have a to the power 7 over 7 here, a to the power 7 over 7 here. Adding their coefficient 1 over 7 plus 1 over 7 is going to give us 2 over 7. It's more like we have one of them here and one of them here. So 2 of them. 2 of a to the power 7 over 7. They equal 1. Now the next thing we want to do is to factor a to the power 7 out since it is a common term here. So we are going to have n to the power 2, a to the power 7. Factoring a to the power 7 out, this place remains 2 over 3, and this place becomes minus 4 over 5, and this place becomes plus 2 over 7 since we factored a to the power 7 out here. So equal 1. So let's add the whole thing here. That is going to give us 16 over 105. So n to the power 2, a to the power 7, multiplying 16 over 105 equal 1. So now let's multiply both sides by 105 so that 105 will take care of 105 here. So we are left with 2n to the power 2, a to the power 7, multiplying 16 equal 105. So let's divide both sides by 16a to the power 7. So 16a to the power 7. This will get rid of that. And then we are going to get n squared equal 105 all over 16a to the power 7. Taking square root of it will cancel out the square root sign. And our n, normalization constant, is going to be 105 all over 16a to the power 7 all square root. So the question is asking us to calculate for the normalization constant. And in this case, we've calculated our normalization constant to be n equals square root of 105 over 16a to the power 7. So we can therefore go ahead and write our normalized wave function as, that is if we are asked to do so, or we can a to the power 7, then x multiplying to bracket a to the power 2 minus x squared. So this is a normalized wave function. So since this wave function is normalized, it should be able to explain probability, give us a probability of 100%, not a probability of 90% or a probability of 120% or a probability of negative 50% of describing the presence of a particle in space. So that is the main idea behind this whole thing. A particle in one-dimensional box of length L is described by the wave function psi of x equal sine n pi x over L for the interval from 0 to L. 0 is less than or equal to x, while x is less than or equal to L. So find the normalization constant n such that the total probability of finding the particle in the box is equal to 1. So in this problem, we've been given the interval from 0 to L, and we have to find the normalization constant. The wave function is not normalized. For it to be normalized, a normalized wave function, we should multiply the original function by the normalization constant. In this case, the question says we should call it n. We should call it n. So we multiply n by sine n pi x all over L. So now we proceed. Integral, the limit is from 0 to L. So integral from 0 to L of psi of x squared dx should be equal to 1. And now we know this psi of x is now, is it equal to n sine n pi x over L. So let's do that. So this is going to be n sine n pi x over L dx equal 1, all squared here. So let's expand what is in the absolute sign or the bracket sign. So n to the power 2 gives us n squared, then sine to the power 2 gives us sine squared n pi x over L dx equal 1. Integral from 0 to L. Since n is a constant, let's bring it out. The integral from 0 to L, sine squared n pi x all over L dx equal 1. We are going to use the trig identities, the reduced angle formula, to simplify this expression. We have sine, if we have sine squared theta, it should be equal to 1 minus cos 2 theta over 2. So in this case, we can rewrite this as n squared integral from 0 to L 1 minus cos 2 theta. All this is theta, right? So we multiply it by 2. So 2 pi x, 2 n pi x. So let's bring n here. All over L, all divided by 2. The x should be equal to 1. Now we can factor this 2 out by multiplying this 2 right here is the same as this whole thing multiplying half. So if you simplify it, it's the same as dividing by 2. So we bring that half out. So n squared multiplied by half, integral from 0 to L 1 minus cos 2n pi x all over L dx equal 1. So we can rewrite n squared over half and multiply by half as n squared over 2 integral from 0 to L 1 minus cos 2n pi x all over L dx equal 1. So rewriting all this in this form, just simplifying this term here, n square over 2. So now we now integrate this term here. If you are integrating cos x dx, it gives you sine x. Cos kx dx, it gives you 1 over k here, sine kx. So let's see. In this case, integrating a constant 2 will give you the constant multiplied by the variable in concern. So if you integrate 1, you are going to get x. Integrate 2, you are going to get 2x. You integrate 3, you are going to get 3x, right? So now integrating 1 here gives us x minus integrating cos 2n pi x over L. What do we get? If we integrate cos, we get sine, right? So what we just did is that we are integrating a constant 1, then integrating this constant with respect to x, we get x. So integrating cos 2n pi x over L, if we have cos x, we are integrating it, we get sine x. But cos kx, integrating it gives us 1 over k. Whatever is here, apart from the variable in concern, 1 over that, then sine kx. So here we have 2n pi x over L. So apart from the variable x, 2n pi over L. So 1 over this, 1 over 2n pi over L. Sine, integrating cos gives us sine 2n pi x over L. Then we now bring in the limit from 0 to L equal 1. So now let's put in the limits. So n squared over 2. So firstly we put in the upper limit. Wherever we see x, we put L there. So x here, so L minus this 2 pi 2n pi over L can also be written as L over 2n pi. It's more like 1 over 2 over 3. It's also the same as 1 divided by 2 over 3. To take away with the division sign, equal 1 multiplied by with the reciprocal of this, so 3 over 2. So it just as turning this over, forgetting the 1. So wherever we see x, we put L there. There's x here. So sine n pi L divided by L. Then minus, we now put in the lower limit. So we have x here. Wherever we see x, we put 0 there. The lower limit is 0. So minus L over 2 pi, L over 2n pi, then minus this minus sign, L over 2 pi, this term here, which is the same as L over 2 pi, then sine 2n pi x, there is x there, so we put 0 there, the lower limit. Wherever we see x, we put 0 there, all over L. They are all multiplying n squared over 2. So the next thing you need to know is that if we have sine pi, it will give us 0. So sine n pi gives us 0. Sine 2n pi gives us 0. So now, looking at this term here, we have sine 2. We should have added 2 here. So there is 2 here. So sine 2n pi is 0. Sine n pi is 0. Sine pi is 0. We have sine 2n pi here. Definitely, this whole term will go to 0. And we have sine 2n pi here multiplying by 0 again. So this whole term will go to 0. 0 will have no effect on anything here. So we are left with L here. So the remaining terms here are n over 2 L equal 1. So we now solve for n, which is our normalization constant. That is what we are looking for. So multiplying both sides of the equation by 2 gives us n to the power 2, L equal 2. So divide both sides by L, divide both sides by L. So we are going to get n squared equal 2 over L. Taking square root of both sides will give our n, our n would be equal to 2 over L square root, or under square root sign. That is our normalization constant. Now that we are done with our normalization constant, we just multiply the wave function that was given to us by the normalization constant. And that will be our normalized wave function. This is the wave function that we are normalizing. Psi of x equals sine n pi x over L. Now that we know our normalization constant to be square root of 2 over L, our normalized wave function would be equal to square root of 2 over L, square root of 2 over L, multiplying the function, original one that was given to us, sine n pi x over L. So if we integrate this wave function, over the interval from 0 to L, you should be getting 1, indicating that the wave function is normalized. Normalize the given wave function for a particle in a box, given that psi of x equal sine 2 pi x. So this wave function psi of x is not normalized, and we want to normalize it. So if the wave function is normalized, it should be in a form, let's say our normalization constant A should be multiplying the wave function psi 2 pi x, psi 2 pi x. So we first have to solve for the normalization constant. But we have not been given any limit. But we know that we are dealing with a particle in a box. For a particle in a box, there is zero chance outside of finding the particle. Outside the box, there's zero chance of finding it there. But inside the box, let's say there is one chance of finding the particle there. The particle has nowhere to go outside the box. It is in the box. So zero chance outside and one chance inside. So that should be our integration limit. So 0 to 1, we are integrating psi of x squared. So psi of x absolute squared. And this is the same as that over here. So from 0 to integral from 0 to 1 of a sine 2 pi x all squared dx should be equal to 1. So now let's simplify the expression. So a squared, we are going to get a squared integral from 0 to 1. Then sine squared, sine 2 pi x multiplied by, to the power 2 is going to give us sine squared 2 pi x dx equal 1. Since a is a constant, our normalization constant, we can bring it out. A squared integral from 0 to 1 sine squared 2 pi x dx equal 1. Now what do we do next? We want to integrate sine squared 2 pi x To do so, we are going to use the reduced angle formula in trig. We know that sine square theta equal 1 minus cos 2 theta over 2. So sine squared can also be written as 1 minus cos 2 theta. In this case, this whole thing is our theta. We are multiplying this whole thing by 2, so it's going to give us 2 multiplied by 2 pi x, which is 4 pi x, cos 4 pi x, then all divided by 2, the x should give us 1. Now, this over 2 here is the same as, it's more like this term multiplying by half, then simplified to be over 2. So we can take half outside, factoring these 2 out. So we can get it to be a to the power 2 multiplied by half from 0 to 1. 1 minus cos 4 pi x, the x equal 1. We just factored 2 out. So now we can simplify this as a squared over 2 integral from 0 to 1 minus cos 4 pi x, the x equal 1. Now we want to integrate this. If we integrate a constant, let's say integrating 1 is going to give you x, 1x. 2 is going to give you 2x. 5 is going to give you 5x. That is if you are integrating. So integrating 1 gives us x minus. So integrating cos 4 pi x, what do we get? If you are integrating cos x dx, what you get is sine x. Integrating cos kx equal 1 over k, the term over here, 1 over k sine kx. Integrating sine kx equal 1 over k here minus 1 over k here multiplied by negative cos kx. So the whole thing becomes minus 1 over k cos kx. So now let's apply this here. So here, the variable that we are working with is x. So anything here that is not part of that becomes our k, right? So 1 over 4 pi. So 1 over 4 pi. And then if we integrate cos, what do we get? We get sine. So sine of everything here. Sine 4 pi x. Then bring in our limit from 0 to 1 to give us 1. There's no need to include the integration constant here. So at the end of the day, it will be of no use to cancel out. Now let's continue. So let's apply the limits. First of all, we put in the upper limit, which is 1. Then we subtract, first of all, let's put in the upper limit. Let's substitute the upper limit here. So we have a to the power 2 over 2. So we have x here. Wherever we see x, we put in 1, the upper limit. So 1 minus, wherever we see x, there's x here. So 1 giving us sine 4 pi all over 4x. 4 pi. Same as, you can write this term here like this. So then minus, we now put in the lower limit. We subtract that from that. So putting the lower limit, x here, wherever we see x, we replace it by 0. So 0 minus, this can be written as sine 4 pi x here, which is 0 all over 4 pi. They are all multiplying a squared over 2. So, Another identity that you need to know is sine 4 pi equals 0, sine pi equals 0, and then sine 0 equals 0. So those are the things you need to know when you are dealing with problems like this. So now we've solved our normalization constant to be root 2, and our normalized wave function. This was the wave function given to us, which we were supposed to normalize it. So after getting our normalization constant, then the normalized wave function psi bar of x equal the normalization constant multiplied by the original wave function that was given to us to be normalized. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.